Hi, I'm Ahmed Yazdi and welcome to Parametric House. In this video, I'm going to first of all give one of our active subscribers a 3-month subscription. So be sure to watch the video till the end. I'm going to announce that subscriber. And another thing I want to explain before we start the tutorial is that the Carnaval chair, or whatever you want to model in Grasshopper basically, can be done in many ways because you have many tools. You can just simply draw a line with 2 points. You can draw a line with direction. You can draw a line with, I don't know, evaluation of a curve. So first of all, I want to say that the tutorials I'm giving you about Grasshopper is not the only way you can do this. You can also always optimize the algorithms. You can always think, and optimizing the algorithms is another step because when you optimize the steps, you have to think about this. Okay, can I do this better? Can I do this in a shorter way? So it is true that if I just record this video again, maybe I'm going to find another simple and shorter or a quick way to model this. So this is one of the tips I want to talk about. And another thing is that be sure to watch the video till the end. Thank you for subscribing to our channel and like our video. Subscribe to our channel. So be sure to watch the video. At the end, I'm going to also tell you who is our lucky subscriber and the active subscribers. Okay, to get started, first of all, you can download this definition from the website so you can understand what the ways you can model this chair and find the steps. So first of all, you can see that I have used the interpolate T in the curve, spline, and interpolate T. And the most important thing about the interpolate T is that you can define the start and the end tangent. So about this chair, you can see that at the top, let's just turn everything off and let me show you the basically chair of this. Turn this off. Okay. If we look at the base curve of the chair, you can see at the top it has a tangent here, which is in the basically y direction. Then we have another one here, which is in the z direction. Again, we have something here, which is in the y direction. Here we have this in x direction. So what I have done is, because I have modeled this in Grasshopper, in Rhino 5, you can see that it tells it's old. It has a degree here, which we don't have in the Rhino 6. So you can see that I have produced this. Let's just turn this off. At the bottom, here you go. We start from here and then come down. Then we have this section. We go up. So we have 2 sections here. And then we have the 3rd section, which comes and goes there. So let's just do this from scratch. I'm going to give this a spline interpolate T. Let's just put the bifocals plugin here. And what I'm going to do is to first give n vertices here. So let's just set this to 0 and bring this here a little bit up. Okay, this is the first of the start of this curve. Then it comes and then sits down. So let's just give this another copy and move this and bring this a little bit down. So you can also look this at the front. We want to sit at here at the x direction, and here we go. So we can give this as a second one, and the start will be the y direction. And you can see that this is in the minus y direction. So let's just give this a minus x, and then we have this in the x direction. So let's just give this an x at the end. Again, a minus x here, and we're good to go. So you can see how easy it is to produce that chair. Then we have another copy. Let's just copy paste this, and let's just delete this one. We have this point, and then we bring that up. So let's just give another point at 0 and move this at the front, bring this a little bit up, and again this is the z direction again. We can start with this point and give the shift key. Here we have the x direction at the start, which is -x, and here we have the z direction, so it's either z or -c, so that's okay. And you can see that this is bringing it back up. So again, we just copy this. Let's just move this point a little bit up. Okay, so it's going to start from this point and bring to that point. Again, we have a z direction at the start, and here we have to bring this out. So if you look at this, the example file, you can see that this is out and then it goes in. So we can simply bring this point out and have a y direction for the tangent and that's it. You can see how easy it is to manage and control these points, and you can also look at the top and move this to produce the thing you want and the results. And here we can just change this and see the results. So this is the most easiest way you can do this. You can see that this is not exactly the curve from the down of the chair. So if you want to exactly model this, you can simply go, for example, at the end. You can also add another point here. So what I'm going to do is to put a copy and move this a little bit up and inside, and say that this is the start, this is the second point, and this is the end. So this will also help you to produce better results. So you can see how easy it is to just change the model and reach the exact thing you want. So I can just also change this and change this a little bit. So this is not really important, but you can manage to produce something similar to this. And you can see that in the perspective, again, we have to bring this a little bit out and make it better. So you can see that this is again has to move forward and move this one up. So I don't want to waste time for this, but you can see how easy it is to produce it exactly as the Carnaval chair. So again, if you want to produce another curve here, you can add another point and another point here. So let's just go and check this out. We can add another curve before this and move this a little bit up. Again, first, second, last. And bring this a little bit down and bring this a little bit up. Again, let's go into the perspective view and see. You can control that point based on your model. Okay, so we have at the end this curve. So let's just go to here. And again, we have this start. We have this end. Let's just add another one. And so this will be the start, the second, and the end. So you can see how easy it is to produce that curve and make the chair. And simply these are the three curves we had to produce. Turn this off to produce the half of the chair. And then we can just mirror the curve to produce the rest of it and produce the complete chair. So now we go to the curve and use the join curve to join them. The first curve, second, and the last. And now we can simply use the mirror tool to mirror this in the XZ plane. This is the XZ plane. And here we go. So this is the exact thing we want. We can also turn on all the control points and move these points. So look at them at the top and move them so you can have a smaller chair or a bigger chair. Okay, so this is the way you can control the points. I'm going to turn this off. And at the end, again, I'm going to join this curve with the mirror. So let's just join this. And the best thing is to check this out. Okay, that's 2, it's 1. And at the end, I'm going to rebuild this. The reason I'm rebuilding this curve is that if you bake this joined curve and explode it, you can see that this has different sections. To make it a unit curve, I'm going to rebuild this with degree of 3, that NURBS, and let's just use 100 control points and bake this. You can see this is exactly that curve, but its distribution of those control points is even, and you can also not explode that into segments because it is one segment only. So this is the steps we have to take to reach the base of that. Okay, so the next step is to produce the sections, and when we look at this from front, these are the sections. One of this is in the Z direction, this one perhaps is in the Y direction because we can't see the Y direction. This section also is in the Y direction, and this is a little bit rotated. So the next step is to produce the sections. So to make this, I'm going to go to let's go to the perpendicular frame tool and extract a frame. After rebuilding this, we can simply reparameterize this, so it's going to be from 0. Let's just check this out. With the point on curve, you can see this is 0. It goes to the 1, which is at the end. Okay, so now we want to have a parameter, so this is going to be 0 at the start of this. You can see that there is a plane here, and I can use the Y direction of this plane to draw a line for this section. So because this Y is a little bit different from this line, I'm going to use a rotate plane and rotate this plane in the Z direction of the axis. So we can simply give this a degree and give this a number. Let's check this out. Turn this off. You can see that I can rotate that. From the front section, you can also check this to give it the right direction. And then we can go to the vector and deconstruct the plane. So I'm going to deconstruct this plane and catch out the Y, extract the Y axis. Now we can go to the curve and draw a line STL, start, direction, and length. Here we go. We have this start direction, we have this Y axis, and then we can just give a number to the length so we can produce that first section. Okay. The next section we need here is this section, which is in the Y direction. So let's just bring this with a point on curve, and as you can see, it's something near here. Maybe we can just give this the direction, so you can control that. But because I need the number, let's just go with evaluate curve tool and give this a number. You can see that that's the 25%. We can just define here, 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 whatever we want, but let's just guess. Let's just work on this. We can change that later. Again, have an STL. The point, the direction will be a Y direction, and then we will have 25.6. This is the length. Okay, we need a -6, so we can just have this in -Y direction and then control this section. Okay, we have this, and now we need this one. So again, let's just copy this and bring this to the half of it because it's exactly at the mid center, and now we need the Z direction, and here it goes. We can just bring this up, and you can see this at the front. We can simply draw this at the Z direction. You can also again use a rotation, something similar to this perpendicular frame if you want to. Okay, the last section is to also define something similar to this here. So I'm going to copy this, and because we had this 25%, I'm going to give this parameter a 1 minus x. This is really easy. Because the whole is 0 to 1, 1 minus x means that we want to be exactly at the mirror of this point. Again, we need this in the Y direction, and the length is exactly the same as this length, which you saw here. Okay, we can give this here and we're good to go. So let's just make this happen. We need a sweep 1. The rail is the curve, so let's just give this the rebuild curve, and now we need these sections. So the first section is going to start from here. Let's just give this the first section. The second section is going to be here with the shift key. Okay, I just missed that with shift key. Again, we have this in the Z direction with the shift key, and again you can see that there's a problem here because we didn't give the section. So again, we say we have an exactly X here, and that's it. You can see how easy it is to produce that chair, and you can change it later with those points with this section thing. And I can also change this in the Z direction. You can see that I can increase that. Let's just turn this off. I can increase that. I can change the point location. Remember, you can always play with those points and produce different results. Okay, so this is the way you can modify the Carnaval chair. And at the end, let's just talk about giving this a thickness. We can simply, let's just turn everything off. You can also see that we can have a rotation here, so we can have a rotation and a different length for the end. So now we need a thickness. We can just say I wanted to show you this also. You can see that if I change this, I'm changing the location of that Y direction. You can see that this is affecting the chair. If you want to sit this on the ground, you can also give this the Y direction just exactly where you want to, and you can see how simple it is to change the definition. You can also add another additional section here and give it to the sweep. Okay, let's just do this. Offset surface, give this a number. And because we want to connect these two things, we can simply use the deconstruct tool, deconstruct brep, and deconstruct the sweep and the offset to get the edges. You can see we have three edges. We have a periodic curve, a link-like curve, again a periodic curve, and that means these two curves are the base of that, and the link-like curve is something here. You can see that's the seam of the surface. So I'm going to use the list item tool to extract the edges. 1, 2, 3. Okay, I just got one more, and again the edges 1, 2, 3, and let's just loft these things together. So the first one to the first one, here we go, we have this one, and again we have another loft, the end to the end. Then we can use the brep join to join this sweep, offset, loft, and loft. And be sure to check out here, we don't have to be the data must not be in groups because we want to join all of them, so we have to flatten this. Okay, flatten, so you can see we have four curves here, four surfaces here, and then we have a singular closed brep, and that's it. You can see that we can simply increase or decrease the thickness and produce the chair. This is really easy if you want to work with this technique and the points. And at the end, let's just talk about the pipes. If you want to produce that pipes, we can simply, let's just turn everything off and go back to the sweep. We can have some points here, maybe division, and then put them towards that curve on the other corner. So if you want to do that, you can simply have a subcurve. So let's just do this. Because the tutorial is a little bit so let's just do this. Okay, that's no problem here. I'm going to go and use the subcurve tool. So let's just do this, the subcurve of this where is that rebuilded curve? Okay, here we go. We had that reparameterized. Now we need to construct domain to show the part we want. So you can just choose that by giving a domain between 0 and 1. That's not really hard. So let's just change this and highlight the place we want to start the wires, as you can see here. We can start from here or wherever we want, and then we will finish it at here, okay, maybe. And then we can simply divide this curve, divide curve, and then we can just give this maybe 6, whatever points we want, we can increase that. And then we want to project that on that curve. So what I'm going to do is to draw a line and define this as the direction of those. So you can see this example. Let's just turn the lines on, give this the line. You can see that we can project that onto that curve. So this is not really important, but for those who want to just finish the model, we can go here and have this intersection of this point projected towards this line into that curve. So this is going to take a little while. So let's just do this. First, I'm going to make a plane based on this line. So let's just do this, give this a curve, and I'm going to go to curve and have that point on curve from the start. Okay, let's just go to the plane vector and make a plane with these lines and points. Construct plane. The origin is going to be this. The direction of the first direction will be the line, as you can see here, and the y is going to be a z-axis. So this is going to give you a simple direction. And now we can project these points based on this plane. So what I'm going to do is to go to vector, plane, and use the plane origin to make planes there. Okay, the original plane is this plane, and the origin of that plane is the division points. Here we go, and you can see that this is the direction we can project that on that curve. So now I'm going to make another subcurve. This is really based on your design. You have to define where you want to project that. So I'm going to start from here to maybe here. That's the safe place we can just define. Maybe I'm decreasing that to get that near that division point. So it just projects on that curve. And here we go. We go to the intersection. And you can see that in the mathematical section, we have a curve plane. This is really easy. This will project, this will intersect the curve, which we have here, with these planes and produce those points we want for the wires. That's it. So let's just do this. Curve plane. The curve is here, the plane is here, and we have those points. Now we can just make them with lines. Let's just do this, the points, the projection, and remember this is in groups, this is not in groups, so perhaps we have to flatten this so they are all in the same groups, and you can see that that's the results. We can simply mirror this. This is really cool. You can see how easy it is to with Grasshopper. You can actually model everything, and that's it. That's the mirror of that. Let's just turn everything off, and we can pipe those lines to produce that chair. Here it is. We can increase the number of division. We can change the direction. Remember, you can't just take that direction too much because it will not intersect. So remember, you can just also change that, and that's it. So you can see how easy it is to model a chair. I can now turn on the control points and move the chair a little bit up. You can see that it will stick on to those wires. We can change this point, and that gives us a parametric carnival chair. So that's a parametric carnival chair, and you can also download this example from the website. Okay, thank you for watching our video, and I want to say that it was a little, not hard, but we had 2 or 3 active subscribers. So the subscriber is Abiodun Shoni Bear, if I just spelled that right. Please email me. I'm going to put the email at the description bar, and register on the website so I can your user, activate your user to the access of the user to the course. Okay, so thank you for watching and subscribe to our channel, and you can also watch something that is related to this video, that corner, and see you next time.